All right, get ready, guys. This is going to be a tough one. For the final part of our talk on sorting algorithms in C, we're going to handle the big baddie himself, quicksort. Okay, he's the most challenging. In fact, a lot of people argue you should use shell sort or merge sort or whatever instead of quicksort unless you really, really, really need the best case performance to be great, because it is a complicated thing to implement. Okay, but we're going to try our hand on it. It's good to know it, just in case you do need that. In fact, I do a lot of embedded systems work. And in that case, you need all the performance you can get. Sweet Jesus. So yeah, I like to know quicksort. I like to have quick, and if I use all of the sorting items. Just because quicksort is generally the fastest, it's not always the fastest. Okay, I know a quicksort, comb sort, merge sort, and shell sort by heart, just in case I need to implement them whenever. You don't necessarily need to know them all by heart, but I like to know them as like different tools for different jobs. Okay, I don't like to compromise. I like to get the best thing I can. So let's get into it. All right, this uses a lot of recursion, and like merge sort, there's a divide and conquer strategy where it breaks up the array. Okay, so let's get into this. First, I pick a pivot number. It's just a number that I'm going to. The idea of this, first off, what I should say is the idea of this is to make sure that we're going to go through pretty much every number in the list. Okay. And we're going to make sure that every number less than it is to its left, and every number greater than it is to its right. Now, if every number in the list has all the numbers less than it to its left, and all the numbers greater to its right, we know it's sorted. That's the definition of being sorted. And we're going to do this in an interesting way, where we break it up into smaller arrays and swap them around in smaller arrays and get those sorted. So it's almost a small taste of merge sort almost. So I'm going to pick a pivot value that I'm first going to pivot the numbers around. I'm going to take everyone less than it and greater than it and start switching them around. Okay. Typically, you pick the guy at the start. So I'm just going to pick 2 here. Make this brush size a little smaller. It's like thick. All right, that's pretty good. So can we make the eraser size? Oh, yes. All right. Now I'm going to pick 2. Now I'm going to start a pointer right above. Okay. I'm going to start here, and I'm going to say as long as the guys to his left are less than the pivot, I'm going to keep moving along. But as we see, 7 is less than 2 or greater than 2. So I'm just going to stop here. All right, I'm already done. Then I'm going to start at the end. Okay, and usually you call this your I or your J. You'll see it called that a lot. I like to call them left and right in my code, but I and J is what you may see. So when we code it today, we'll probably just call it that, so you kind of get used to the standard. And then when you're coding it by yourself, maybe you can do whatever you like to do, whatever helps you understand it better. I'm going to start with J. I'm going to continue on until I find something less than our pivot. So I'm going to continue on. 9's not, so I'm going to jump down to 1. Ooh, 1 is less than our pivot. So I'm going to switch them. So I'm going to switch 7 and 1. Okay. Let's jump up to the thick size again. Boom. Okay. And then I'm going to continue down again. So I is going to jump up to the next guy. He's going to say, is 8 less than 2? No. So I'm going to move him out of here. J on the other hand is going to come back again, and it's going to look for a value less than 2. 3? Nah, not less than 2. Here. Oh, nope, that's not it. But then he's going to jump here. And he's going to say, ooh, that's a value less than 2. But wait a minute. J is past L. If that's the case, we know that in this, if we know J has passed I, we know we've already taken all the numbers smaller than our pivot and thrown him to the other side. Okay, because J is past the threshold. We kind of imagine that we've put in our pivot in the middle somewhere. If that's the case, what I'm going to do is I'm going to break out of this loop. I'm going to switch wherever J is at with 1. Okay. Now you may say, but I just switched some numbers. I've screwed up the order. Well, have I really? If I switch our pivot with the guy that keeps going down, basically J will stop at the end of all the guys less than our pivot, right? So if I just put our pivot right there and just throw him back at the beginning, I still have everybody less than him on the other side. You can see that right here. You see that everything less than 2 is on its left, and everything greater than 2 is on its right. Once j passes I, you know j will stop at somebody less than the pivot, and at that point, if it's past I, we know we're now on the side, we're on the already sorted side, where we've already been throwing people. And so if we put our pivot at the end of that, we know he's at his perfect spot, because everything to the right of him is bigger than him, everything to the left, even though they're out of order, is still less than him. Okay, and so now what I'll do is, I remember j was pointing at 2. These erasers are really bad. What I do is now I partition the array by taking this point here, okay, and I call it, I return this outside of the function. And I come back into the function, splitting it here and here, because we know 2 is in his right spot. So I don't need to compare him with anybody anymore. I don't need to swap him with anybody anymore. He's perfect. So any future comparisons do not need to involve 2 at all. If that's the case, I can split this array up and take this side over here, which in this case is just 1, and this side over here and do the same process. So let's go over here. 1, well, I look at its pivot, and I start with I, okay, and j, and we see that I and j are the same thing, so I'm just going to put 1 right there and say I'm done. You can check the size. That's one thing, too. You can check if the size is 1, you know it's already sorted. So in fact, in this case, I would just return 1 and just say, boom. In fact, now we already have 2 guys in the right spots. Wow, we're on fire. In this case, I would take my pivot as 8, and then I would start again. I would start here with I, and I'd start here with j. And so let's start with I. I'm going to find somebody greater than 8. Okay, not greater than 8, not greater than 8. Ooh, greater than 8. Okay, let's start with j. Not less than 8, not less than 8. Ooh, less than 8. Oop, but j has passed I. So we know that right here is the final part of all the numbers less than 8. Oh, sorry, 7 was less than 8. My bad. But we see that j still has passed I. So j must be at the end of all the numbers less than it. So we're going to now quicksort. I understand that quicksort is very hard to understand. I mean, it took me 3 days of studying until I first understood it. Now I can just pop this baby out. Everything comes with practice in programming. Just don't worry. Boom. So now I know 8's in the right spot. So what am I going to do now? Well, first I'm going to try and erase all this garbo. Maybe we can get a good amount of it. Yeah. All right, that's a good portion. You got to make noises when you program. So I'm going to split the array here. I'm going to split it here. We see I have a list of 1 here, so I will just check that off. It's on the right spot. And now we have an array of 2. So I'm just going to partition by this is my pivot. I will start at 3. It's at the end of the list, so it'll just stop here. J will come, and we'll stop here as well. And J sees that it is equal with I. And if that is the case as well, you also switch them. Okay, since we moved it here, we're going to split it down here, but we see we have an array of 1, an array of 1. You always keep track of the indices that you split it around. So I would do everything within these bounds. And you will see that. And now we have a sorted array. Perfect. So it's not it's not a terrible sorting algorithm at all. In fact, it's highly efficient. It's considered the best in most cases. Some cases it's not. I'm not going to talk about those mathematically. There's plenty of videos going into the theory of when it's best, when it's not. I'm just going to give you an idea how to implement it and how to code it. Okay? So I've already pre-coded a couple things. I've done printless, and I've done, it just prints out the array as normal. I always do that. And we have 2 functions, partition and sort. So like merge sort, it requires 2 functions. You could probably take care of it in 1, but we're just showing you a general way of implementing it. Okay? All right. But as you see, unlike merge sort, we don't need another array. We don't need a separate array. So it's tiny on the memory front. So let's get them both typed out. I'm just going to copy their declarations. Control-C. Copy-paste is it's life, man. Okay, and you'll see that partition returns an int. Okay, it returns. So we have to input the bounds of that section we're going to be, messing around with, hand gestures, and we also have to return that guy that we're splitting the new arrays around, right? That final pivot point. So in sort, I'm going to start off by saying is low less than high. Because remember, if you watched merge sort, if you haven't, I'll still explain it. If low is less than high, we know that they're at different indices. And in that scenario, we also have a list that is greater than size 1. Because a size 1 list is already sorted. Why waste our time? So I'll just put an else return. Now you don't need this return because the function will automatically end after it. I like to put it in there as an else return just for me to view that if this isn't met, I'm just going to end the function. Okay? Kind of a nice, just easy way for me to see it. You don't need to put that at all. Okay. Just do things, as long as they're not radically inefficient or making things really ugly and everything, do code in a way that helps you understand it. No matter what the flame wars of putting tabs versus spaces, or I know I used to fight about this one where you leave comment versus putting a space on it. I used to hate if you put spaces, but do whatever helps you code. Okay, it's such a hard profession as it is that might as well make it more comfortable place for you. So what I'm going to do is I'm going to start off by partitioning the array. All right, we can just start off with the array and start flipping things around. I'm going to put in my nums, and then I'm going to put in the low. I'm going to put in the high. Okay. Now these are indices. These aren't like sizes. These are the actual indices, like 0 to 5 if it's a 6-element array. Okay. I'm going to partition it. And I'm going to get back that pivot point. I shouldn't say pivot because we called something else pivot. But that point on which I'm now on either side of that, going smaller and smaller, I'm returning that point where it is. I know that number is in the correct spot. So then on the other sides of it, I will start sorting them. Okay. And to see that, you'll see me go sort, call it twice, one for each half. You'll see me do sort low. I got to put in nums again, but sort low. And then j minus 1. So I'm getting, we come back here. I'm getting, back in the beginning when it was just 2 here. This is my j. This is my j minus 1, everything to the left of it. Okay. And now over here, I'm going to use high and then j plus 1. J plus 1 is my new low and high. Okay? Not hard. Well, it's a little confusing. I shouldn't say that. Ooh-ba-doo. Getting ahead of myself here. So I'm going to do int. We want to remember what low and high are. So we want to make variables to hold what they are so that we can mess around with without disturbing. I'm going to call it right. I'm going to call it left. I like to start with left. I'm a lefty, by the way. I used to play baseball with both hands, actually. I could pitch with both hands. I was pretty crazy. Played high school ball in California, Cal High, if anyone goes there. So int left, right, got voted most spirited. Those were the days. Left, right, and int pivot, which will be equal to that first number. Okay? Now we're going to keep running until we've hit the scenario. I'll even just put it in now. If left is less than or equal to right, break. This is the condition we're going to break on. Okay? Now, we're going to start with I. Remember, we're going to keep going up and up and up and up until we've hit somebody that is bigger than the pivot. So I'll go while nums first. I have to set left is equal to low. If you've watched previous videos, you'll see that's a common error. I forget to set things. Well, nums left is less than or equal to, also works. Pivot. Okay. Left plus plus. Now we're going to find j's guy, right? And we'll go right is equal to high. Ooh. Just knows a bug. We'll keep assigning it to low every time we come back in the loop. So I got to out here go int left is equal to low, int right is equal to high. Whew, that was almost a little buggy bug.
Hey guys, welcome to our
Whoops, that's another video just got done rendering. It pops up. I was shell sort. That was a shell sort video. It got corrupted, so I had to take it down. Now I'm re-uploading it, non-corrupted. So, well, it is greater than pivot. So in this case, we have J, and as long as it's greater than, we know it's in the right spot. So we keep going until we find somebody that's not greater than. Right, minus, minus, because we're going down now. Okay. Now, if left is less than right, we're going to break out. Otherwise, we're going to swap them. So I'm going to go, I'll make an integer up here, call him temp. I will go int temp is equal to nums right, and then go nums right is equal to nums left, and nums left is equal to temp. Because if I just go nums right is equal to nums left, and then try to assign that previous value that was in nums right to nums left, it's just gone, right? So I need to make a temporary guy to hold it. If I have the two dudes, and I just overwrite the one with the other, I don't have that previous guy to swap them with. So I just pull a copy of them out, overwrite it, put the other guy in. Good to go. Okay. Now, if we've broken out though, okay, we're going to swap the pivot with wherever J is, right? So int temp is equal to nums wherever J is. J is right at that point. If it's supposed to be whoops, that's there. If right is less than or equal to left, because right's this guy and he's passing, right? I get confused with my directions a little bit. Whew, I'm getting better at catching errors, man. It's good. You guys don't want to see me fixing those. Makes it easier in editing, because I don't have to keep stopping the video and then sync up the audio. And enough of my problems. So int temp equals nums right. Nums right is equal to pivot. Okay. Just to make it clear what I'm doing, the pivot's in nums low, right? So I'm just going to do nums low. And then I will say nums low is equal to temp. I've just swapped them. Pretty easy. You can make a function that's called swap nums and just put in the numbers and have it do it for that all for you. It's not a big deal. I do sometimes I do that, really. Sometimes if I have a lot of swapping going on, I'll just make a swap nums function. So let me look this over. If nums left is less than we'll pivot. All nums is looks good. Otherwise, yep. Nums equals nums right equals nums low. Nums low is equal to temp. Yeah, no, that looks great. Okay. Let's do it. If there's any errors, I'll pause it and stop it. Oop, there's one. Oh yeah, I already declared temp. Oop, oh. Ah, we got one. Alright, let me pause it. Fine. I bet I didn't assign something somewhere. Int right equals high, left equals low, and temp equals nums low. I'll pause the video and I'll look for it real fast. Alright guys, the errors were actually really minor. One was I forgot to return right, because remember we need that for J here to be able to partition it. And then the other was, I talked about it before, is we need to make sure that left doesn't, when it's coming up, it doesn't go over the array, right? I talked about this before, it stops at the end. So I just need to make sure it's less than high. High is like the highest index, so if it's, say 1 less than high, we add 1, now it is high, and it won't do this anymore. If I did this, it would still work if it is the highest index, and it would still get incremented above that. So I'm just going to make it less than. And that's it, really. We don't have to do it for here. We don't have to make sure this guy's bigger than 0, because remember we said as long as he's bigger than the pivot, and the pivot's the guy at the beginning. So while he's going down, 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 when he hits the pivot, he'll stop there automatically. And if that happens, it means he didn't find anybody bigger than the pivot. And it means if I got to the end, he didn't find anybody less than him, meaning if they switch the final two guys, that's good, because he should be at the end, right? There's nobody that should be to his right. Okay? That's good. And yeah, if we run it, voila, perfect. So that's basically quick sort. I always call it shell sort. I have to unlock my phone to pause the recording. But yeah, I hope you guys learned something. It's you know, you should probably go over this. I'll probably do another review video where I just go over the code itself, because it's a pretty difficult algorithm to understand. So I hope you learned something new, and I'll see you next time.